All right, we're back. We are Game 2005 in the fall 2018 semester at George Brown, and that's game physics. And we're doing more in SDL. We're going to complete our little MailPilot demo. And just to reiterate again, Friday there won't be any tutorial. So people who normally come on tutorial on Friday, there won't be anything there. And next week, again, you're going to get your take-home exam. That was weird. Crap out. No. So the take-home exam will be based on some of the stuff we're doing today. All right. So to start off, please download the template from Blackboard. Right. So it's template version 4. I'm going to just change my display settings so you guys can see Visual Studio a little bit better. Here we go. Excelente. And then I'm going to go into our courses, and I'm going to grab, so this is the template version 4. This is what you would have got from Blackboard, right? And let's suppose I'm going to go into our section today and paste it in. You would download it, unzip it, right? Please completely unzip it or extract it. Sometimes one of the problems people are having is they don't completely extract it. They try and work by double clicking on the actual zip file. That's not good. Don't do that. Once you've extracted it, then you can just, when you kind of click into it, you can go to the solution file, double click, and make it work from there. And one day when my Visual Studio just decides to come up, here we go. All right, so yeah, Visual Studio. So Anton is not working?
I can't find the include files.
Wow. So yeah, so in Visual Studio, you're going to go to Solution Explorer, and first thing you do is you change from x64 to x86. You need to do that. If you don't do that, then some of the include files will be not found. All right, so that's the first thing you do. And then after you do that, when you've done this, the next thing you have to do for the most part is retarget your solution. So you can click on the project itself or the solution. Let's do the solution this time. And if I go retarget solution, which is right here, then it'll bring up the latest your SDK. Choose the SDK that's the one that you want to use that works for you in your system. And once you've done that, it's going to change your project so that we're all good. And to test it out, to make sure that things are good, what you should do is you should run your project. So what you should get is something that looks like this. This is from last week, right? So so what it's going to do is rebuild everything, rebuild all the references to the executable and so on, and the lib files. And what you're going to have is something that looks like this, a little island that kind of comes down. If you kind of hover over the island, it says collision with island. That's what we have from last time. It's pretty simple. And now we're going to add some additional classes. So I'm going to close this off. So just to revisit some of the stuff we did last week, we created a collision manager, which we used a public static. Oh yeah, I upgraded some of this stuff. We'll talk about this in a second. I created a public static call to something called check. I've changed it this week to squared radius check. Let me explain this a little bit. Actually, I did this in class, and I guess it got kind of translated over here. And that's fine. Let's take a look at the source file for squared radius check. So if I go to my collision manager CPP, you can see that I've created something called squared radius check. And it's different than the distance calculation last time. We used GLM distance, and GLM distance was use square root, and that would be bad, right? So to avoid that, I created our own custom distance calculator. So what it does is it takes 2 points, point 1 and point 2, and basically the differences of x's, p2.x minus p1.x, and the difference of y's, p2.y minus p1.y, then took the squares of those, added them together to get the result, which is the square distance, right? And now that it's a square distance, we also have to square the half heights, which is what I've done. I've squared the half heights, and I'm basically comparing squares. That's how it's working, as opposed to using a square root. Once you use a square root, it's computationally expensive, especially if you use a square root combined with some kind of power calculation. Other things we've changed is we have this little switch. This switch is working because in the GameObjectH file, if you look at the GameObjectH, there is an enumeration, or an enum. That's what it's called. And I have several different types. I've called this enumeration GameObject type, and you have island, player, cloud, bullet, and enemy, and so on. And in my collision manager, I basically use a switch on type. So I set the type for each object, and basically I say something like, well, what kind of type is it? If it's an island, do something. If it's a cloud, do something else. So this is where I've kind of set this stuff up for you guys, so you have everything ready for the next step, what we're going to add next. Is everyone clear on this stuff? Of course you are. All right, and let's go into one more thing is Sound Manager. I mentioned that we included the Sound Manager last time. So Sound Manager actually uses something called SDL Mixer. There's two types of sound. There's also an enumeration for this called Sound Type. And Sound Manager uses two types, a music type and a sound, or a special effects type, right? And then there are a few different methods we can call. One of them is the load. When you load the file, it stores it inside of a map file, just like we did with our textures, whether it's for sound effects, a chunk, or music. And so that's the way the Sound Manager works, using a singleton and so on. And this loop option, this loop parameter, basically if you set it to -1, it'll play that sound forever, right? So kind of very simple sound making capabilities. When we get to, I'll show you how it goes. All right, so now, so challenge. What I want to do is I've got my, again, going back to this, I've got my little island flowing down, but it really doesn't look like much of a scene. I want to have an ocean in the background, right? So again, I'm just setting it up and reviewing SDL here, okay? So this has nothing to do with collisions. So I want to create an ocean class. Okay, so number one, when we go to the header, I want to add a new item in the header. Let's do this together, guys and girls. Notice that on the bottom, by default, the location for the header is pointing to the wrong place. It's pointing to template because that is the default directory or folder that it's going to be placed. We don't want this. We want to change this folder to the source folder, SRC, the source folder, right? That's where all of our files are going to be. So we want to change this folder. If you don't retarget your folder to SRC, it's not going to work. I want to make a header file. The header file is going to be called ocean. So let's just change this to ocean. And I'm also going to make another CPP file, right, in the same place, add new item. Again, I'm going to look at CPP. It's pointing at the same place inside the SRC folder, and it's going to be called ocean. So we have two parts, right? Immediately in the ocean.cpp, I'm going to make an include that includes the ocean.h, right? Also in the CPP, I'm also going to refer to the game.h because we want to reference the game itself, right? So those two things. In my ocean.h file, though, I need to do a couple things. I'm going to kind of do a preprocessor command, if not defined, and if not defined __ ocean. We've done this before, right? I just, instead of typing it, I just copied it. I'm going to define ocean, right? And then at the bottom, what I'm going to say is something like defined ocean, all right? That's kind of like the pattern we've been using. We want to include, ocean is going to be a game object, so we're going to include GameObjectH, right? One. And I'm also going to include the texture manager.h here. Now, you could have included this in the CPP file as well, but definitely those two are fine. Next, I'm going to declare a class. The class is going to be called Ocean. It's going to derive from, that's colon, my public GameObject superclass. There it is. Okay? We have two sections in there. We have a public section and a private section. I know that because it's deriving from GameObject, I have some virtual abstract methods we need to include in order for this to work, right? Because if you remember from GameObjectH, GameObjectH includes 3 virtual abstract methods. This is the way you do virtual abstract methods. You use the virtual keyword and you make it equal to 0. That's the syntax, right? And because I've done this, these must with a capital M, they must be overridden. If they're not, your class will never work, right? So going back to the ocean.h, I need to include these. And the way to do that really fast is to right click on Ocean. And if you go to quick actions and refactorings, right, you can say that implement all pure virtuals for class Ocean. And if I do that, it actually does some of the work for me, like this. So it actually creates the stubs for each of the methods in my CPP file, as well as writes down some of this. Does it automatically for me. I don't have to do all that stuff. So I don't want this here. I want this to be in here, right, inside my public area, because these have to be public. So again, this is my ocean, right? Now, just like we did with island, I have several different methods. One of them, additional methods to this. I also want to include a move method, which is going to be private. So void move. I'm using the underscore to denote that it's private. I'm also going to say underscore check bounds. We did this last time, where we check the boundary on the bottom boundary, as well as another one that is reset, which resets our object back to the top of the screen somewhere. We need these methods. I'm just setting up the ocean. And then I need my constructor and destructor. Okay? So we're going to have our constructor, which is going to be called ocean, and our destructor that's also going to be ocean, right? Those two things. Now, with all this, I can simply just go on the method itself and click on the create definition of each one of these things and create the definition quickly by using my refactoring. It would be nice if we had all the other ones we could select too, but it doesn't quite do that. You have to do them all by itself. So example would be if I click on this and I go to create definition, it'll do it all for you, each one. I can just click on this, click on the little light bulb and go create definition. I don't have to do that myself. I can it just does it all for me, thank God. So that'll be a lot of finger typing, and sometimes we make errors when it comes to this stuff. And this is just syntax, right? So we want to kind of avoid some of this stuff, and let's make the IDE work for us a little bit. Okay, cool. So we've got all this stuff. This is what my ocean.h looks like. So that's what yours should look like now. Are you with me? So nothing too crazy, right? That's all the stuff you should already see. Does anyone have a problem with any of the stuff we've talked about so far? Guys, so you're going to be on your own next week, right? Remember, there's no physical, I'm not going to be physically here with you. You're going to probably be doing this from home or somewhere else, and you need to do this on your own. So you need to understand how to do this stuff. And plus for your assignment, yes. What error? The what? Yeah, you have to put this down here, right? So when you do if not defined up here and define on the bottom, you have to put an end if. If you don't do that, then this preprocessor command that's happening, right, won't happen. It needs to go through this, right?
It should have just included it.
Yeah, depending on how unless you copy paste, right, then it wouldn't do it. All right, so we're good. I think we're good here. Let's go into my CPP file, so ocean.cpp, and take a look at stuff we have to do. So one thing to do is take a look at the island.cpp as a template. So here's my island.cpp. And notice what we're doing here in the island is inside the top of the island, we have a couple things. We have our texture manager loading the island.png as part of it. We have our getting the size of the island. This is what we're doing with the island. We're setting the velocity of the island. By the way, the velocity of the island and the ocean should be the same because the ocean can't swim faster than the island or vice versa. It won't look good. Is colliding is something we set as false. And we also set up the island, the game type, game object type, right? So all of this is really good to use for the ocean. So if I copy all this stuff and go to the ocean.cpp and paste it inside of my constructor, all I have to change is this, which is ocean. And instead of PNG, I know that it's a GIF file. We can change that, the friendly name for the ocean as ocean. We're getting the texture size of the ocean, not the island. And the game object type hasn't been defined. We have to define a game object type down here. And the way to do that is if I go to my Solution Explorer and if I go to my project and bring up GameObjectH, notice that there is not a game object type in GameObjectH. We just have to define that. I'm just going to make a new one called Ocean. And once I've done that, I'm good to go with changing this down here to Ocean. Right? So again, all I did was I went to GameObjectH, added an Ocean enumeration, right? And then in my ocean.cpp, I put in Ocean. I got all this code for the most part from my island.cpp code, which you have. If you downloaded this from Blackboard, you have all this. I just copied this and modified it and put it into the constructor. Now, things to note, right, is we're copying. And anytime we copy, and especially large amounts like this, you got to think to yourself, is there a better solution? Because if I'm copying, I'm repeating myself. And one of the rules of programming, I guess a method or kind of a thought is we use this mnemonic dry, which is do not repeat yourself, dry, right? And we're repeating. So that means that there's an opportunity for us to either include some of this inside of our GameObject superclass or create a second superclass that we can derive, perhaps an actor superclass. And again, good thing about C++ and the bad thing about C++, it allows multiple inheritance if you really want to. You could include some of these things inside of another class, or just include it in your GameObject superclass. Okay, so this is the constructor. This is where we load the object up, the GIF file. All right. Now inside my draw functions, the next thing we're going to tackle. So. Sorry, what was that?
No, can you go back to ocean.h?
Sure.
Should be two, right?
GameObject and texture manager.h. Yeah. All right, so yeah, so we have this. We're going to add to the draw function. Again, I'm going to go to the island CPP, and I'm going to grab the draw stuff from the island. Again, we're copying. And we're pasting inside Ocean. It's more or less the same. We're just going to change the island to Ocean. Again, this is a great case for doing something with the GameObject superclass somehow. All right, cool. So here's my Ocean. Great. Here's my Ocean update. Ocean update, I'm going to do move and then check bounds. Those are the two things we're going to do in the Ocean update. We're going to move our object and then check the boundary for the Ocean, right, to see if it's reaching the bottom of the screen. And let's talk about what this Ocean is before we continue. If I actually look inside of assets here for a second, inside textures, there is this ocean.gif file that I've included for you guys. If I double click on this thing, it's actually quite large. It's 1440 by 480. Or sorry, 640 by 1440. I'll be all right. All right, so if you look at this thing, it's massive. Look, it's really big, right? It's not a small texture. So what I wanted to do, let's suppose that I have my viewport, and this is my viewport here. Let's just make it so that it's transparent, and we'll make it so that we give it a bit of a border that is, I don't know, we'll make it yellow so we can see it. Yay! And we'll give it like, I don't know, some kind of thing like this. Let's suppose that this is my viewport, right? And we'll just lock the Ocean back here for a second. We'll move this thing so we can move this around. So take a look. So if this is my viewport, then what's happening is most of the ocean is off screen, right? Most of the ocean is off screen. So what I want to do is I want to start scrolling the ocean 5 pixels per frame. That's what I'm doing. So what's happening is the ocean's going to move down like this. This is what's going to happen in the game. It's going to come to this point right here, right, where the top of the ocean meets the top of the viewport, and then reset back to the top, which is going to create the scrolling effect. It's going to scroll forever. That's what it's going to look like, right? But what's really happening is there's only one ocean, and all we're doing is resetting it back to the top of the screen, okay? So in our move, if I go back to our code now, if in our move function, my move function just moves us down, my check bounds checks the boundary to see if it's hit the top boundary. And if it does, we reset, okay? So again, if I go back to my island.cpp, in my move function, this still holds true, this stuff. This is all good. So all we're doing is, you know, calculating the new position based on the velocity, which is still the same as the island. So copying this part and moving it into here. And for boundary checking, this is where we're going to say something like this. We're going to say if my get position, the position of the ocean, right, dot y, if the position of the ocean dot y is greater than or equal to 0, then we want to reset. One more thing we have to change before I forget is when we draw the ocean, I just copied and pasted from here, from the inside here. But notice what we have in our draw method is we have the following requirements. One of them is, hey, the name of the friendly name of the ocean, the X component, the Y component of where I'm going to be drawing it every frame, the renderer, which I'm getting from the game, right? And then this little true. True is actually saying that the ocean graphic should be centered, but that's not good because if I center the ocean graphic, going back to the little diagram here, then it would be like this. So the ocean would be centered up here somewhere, right? And that's not good. We don't want it to start over here, right? We want the ocean to start here, right? Which means we don't want it centered. We want the top left corner of the ocean to be its pivot point, right? So what we want to do in code is make this false or just delete it. If we just delete this part in the draw function in the ocean, that should take away the centering pivot point. Yeah, so if you actually look at the draw, when I made this method, I created an override and I created defaults. Okay. All right, so there's the check bounds, and now the reset. So where does it reset? I want the ocean to reset off screen. The ocean is actually 3 screens high, and because it's 1440 pixels high and the screen is 640 pixels tall, the actual viewport, it's going to be offset 960 pixels to the negative off screen. So that means when I reset, I want my ocean, the position, I want to set my position to a new position off screen. I'm just going to use a new GLM Vec2 object, which is going to position the X component at 0 and the Y component at negative 960. All right? That's just negative 960 pixels off screen. And that's what's going to happen every time I reset. That's it for the ocean. That's all it's going to do. I'm not checking collisions with the ocean. All I'm going to use the ocean is a background graphic so it doesn't look so boring. And also, this is great review for you guys when you look at SDL, how we're using it, and the way we're creating objects, game objects in SDL, right? We good?
Where'd you get check bounds from?
This one? I made it.
No, that one.
This? I didn't. I just typed it in. Yeah. I copied most of it, but I have to actually type some of it. Otherwise, I'm just copy pasting, right? So that's not too good. So yeah. So I mean, I'm just being lazy. I could probably have done the same thing, but it's already there. Again, think about this though. If I'm doing this every single time, there's something to be said about putting this inside of another function or something like that. Okay, so continuing. So now that I've got my ocean, I'm good, but here's my problem. I haven't really connected it to my game. So the way to connect it to my game, if I go to my Solution Explorer, I need to bring up my game.h. I need to include the ocean. And by the way, let's just organize some of these includes. So here's ocean.h. I want to organize it. So I want all my managers together. Let's put my managers up here together. And we'll call this, these are the managers. Right? And these are game objects. Right? And maybe these are some SDL related includes. And there's other ones I could include here too, but I'm not right now. Cool, so I've got my managers and my game objects, and I've got a reference to my ocean. I need a reference to my ocean in order for me to draw my ocean, right? Because otherwise I don't know what I'm doing. The game doesn't know what the ocean is. And what I want to do is I'm going to go down to the private area, and I have some game objects I've already defined. I'm going to define another one called ocean. It's going to be an ocean pointer, which we're going to call m_p ocean. Okay, so two parts to this game.h I modified. One is I added an include up here on the top for the ocean, and the other one I just added a pointer to an ocean object. That's what it is. Okay, now that I've got this done, I need to do something with the ocean that I got inside of my game.cpp. Again, just like I did last time, I have a create game objects method. And I'm going to put my creation here. So I'm going to say m_p ocean is equal to a new ocean. I'm using the new keyword to allocate memory on the heap. Okay? So I'm doing that inside of my create game objects. Are you with me? All right. Once I've created the game object here, and line 27 of my create game objects method, I need to, you got this? I need to draw and update it. So in the renderer, now, question. I want my ocean to be drawn first. Where would I put it? In terms of, does order matter? What do you think? Yes, it does, right? Like we talked about last time. It's got to be here, m_p ocean, and we're going to draw. We're going to use the draw function of the ocean in order for us to draw the ocean first. Okay, so it's going to draw underneath the player. And then in my update function, I'm just going to update the ocean. m_p ocean update. And, you know, to be for completeness, I probably should put these in the right order, but it doesn't really matter. Not really. All right, cool. So we've got everything we need now. And if I did everything correctly and if I didn't mess up, we should see something that looks like, after I build it and run it, this, right? And it should scroll forever. Janky. But it's not bad. So again, we've got our collision, we got a collision over here, and we can keep colliding. And what we have is this little file that, you know, that runs, and we have pretty good, you know, looks like a game. Okay, does anyone not have this? Yeah. That's the draw function. All right, so look, we've gone and done a background. Is anyone not clear about how to create game objects now in SDL? I've done it, or in our framework we've created. If anyone's not clear, you may have to create some for your assignment, right? So this is something you have to do, and for your exam, right? So you need to know how to do this stuff, right? Okay, moving on. Are you good, Nicholas? Are we good now? All right, so yeah. So what we want to do now is I want to create, this is interesting, I want to create a cloud object. So again, I have a cloud asset. And now here's the thing, we're going to use multiple clouds to collide with. So now this is the first time we're using multiple objects, and this should satisfy your assignment 3 requirement for part 2, which has multiple bullets coming down, and you're colliding with multiple bullets one time, all right? So, but instead of bullets, I'm using clouds. right? Let's make a cloud. So I'm going to do it a little bit quicker this time. So again, I'm going to make another game object called cloud. So let's do this one more time, right? Again, repetition. So I'm going to go here. Notice it's going to be in the right space. It's going to go into my SRC folder. I'm going to make a new header file called cloud. Let's see if you guys can beat me at this. Let's set your stuff up, guys. Here's my cloud.h. I'm also going to make a cloud.cpp the same way. A new item, a new CPP file called cloud. And in my cloud CPP, I'm going to include the cloud.h. It's a race. Let's see if you guys can do it faster than me. I'm also going to include the game.h. And then in my cloud.h, I'm going to define it, if not defined, and __ cloud. Then I'm going to define my cloud. And in my cloud, I'm going to include my GameObjectH. There it is. And I'm also going to include my texture manager. And then I'm going to start defining my class, which is called cloud, which inherits from a public GameObject superclass. And inside there, I'm going to have two sections, public and private. And in here, like I talked about before, in here, what I want to do is I want to right-click on the cloud, go to Quick Actions and Refactorings, and implement all pure virtuals for the class cloud, which does all that work nicely for me, right? Thank you very much, Visual Studio. But I'm going to take all these pure virtuals and move them into the public area. There's my public area. I don't want to do that by myself. I know the cloud is going to have those three functions I used before, our move function, our check bounds, and our reset function. So those functions we're going to have, again, lots of repetition. And they're all returning void, of course. Take care, Victor. They're all returning void. And I also want to have some constructor and destructor. By the way, you could have copied and pasted and beat me faster. And we're going to go cloud for my constructor and then my destructor. And then we're going to implement them by clicking on them, clicking on the little light bulb and defining all those methods one at a time. So we don't have to do any of the typing ourselves. And it reduces errors, I find, as opposed to you typing it by yourself. Some people are really quick. They can type it faster than I can actually use the light bulb, but that's fine too. Okay, cool. So there's everything. This is the stub of my class. Guys, you should have this pretty much down, right? This is like, you know, the basics that you need for any class that you're going to create. Any object right now, game object. And by the way, like I said before, if this is what we're going to do, then we should think in the future, if I was going to extend this concept into a full game, I may want to consider move, check bounds, and reset as more pure virtuals that I would assign inside of the GameObject superclass, because I've been using it every single time, right? Okay. That's pretty cool. I've got everything going. And now to make my cloud work, haha, look at this. It's called Cloud CPP. Haha, that's terrible. So let's rename that Cloud CPP thing. That is just not right. It created cloud and Cloud CPP.cpp. Wow, that was bizarre. I don't know what happened there, but I must have made a mistake. So let's just delete that. I'm just going to remove that and not worried about it anymore. And all I care about is the cloud. To do cleanup, by the way, if you ever make that kind of mistake, I recommend you also look in your folder in your file explorer. Inside the SRC file, make sure that there's no extra files like cloud.cpp.cpp. That could mess you up later on when you're searching through. So just get rid of it. Okay, cool. yeah, so we're good. We have our cloud and our cloud.cpp. Here's our cloud.cpp. This cloud.cpp is where I'm going to get the same kind of stuff. I'm going to use the ocean or the island as a template. Let's go island. So again, I'm going to go back up here to island. I'm going to grab all this stuff from the island, this stuff, and copy and paste it into the cloud. So inside the constructor, and just change the names here. So instead of, oh, see, this is bad. Oh, it's really messed up. Yeah, so this should be called cloud and cloud, and this should be cloud. And now, my velocity is wrong. What I want the clouds to do is I want the clouds to be a little bit different than the islands. I want them to reset, but I also want them to have a variable speed, a variable velocity. So they're going to be, some of them are going to be faster, some of them are going to be slower. Some of them are going to drift to the right, some of them are going to drift to the left. And it's all going to be random, okay? So let's see how we're going to do this. So this set velocity thing on the top here for the cloud, I'm going to take it out. I'm going to put that in the reset function, actually. Okay, so we're going to do the velocity setting later. All right, so this is pretty good. This is our cloud constructor. We're also going to go into my island and grab the draw function and copy paste that in there. Again, this is pretty bad, but it's okay for now. And here's our cloud. We definitely want this centered, so this is going to stay true, right? This is going to stay true. And again, I'm going to take the island, and for the move and check bounds, I'm going to copy that into the cloud. I'm going to be really lazy now. I'm going to type that faster. My move function is going to be more or less the same as the island. I'm going to still do this. So I'm going to copy paste the move method into the cloud.cpp. I cut that out, yeah. In the constructor, I took velocity, set velocity out because I'm going to put that in the reset function, which is going to be different. And then in my island.cpp, where I check bounds to the bottom, I'm going to still do the same thing, exactly the same with my clouds. So I'm taking this check bounds is almost exactly the same. It is exactly the same. Here's where we change stuff. We change stuff in our reset, but I'm going to still copy all the stuff I already have in my island. So in my island reset, this is the only real change I'm going to make. I'm going to grab all this stuff from the island and copy it into the cloud. Okay, and this is still all good. However, what I want to do is I want to set my velocity to some new velocity, and I want to have two, right? I want to have a velocity on the x-axis, right? And I want to have a velocity on the y-axis, right? So I want to have two. So velocity x, right? And I want to have another one, velocity y. And I want to also have my set velocity, where I say, well, I'm going to set the velocity to a new GLM vec2 object, which is going to have two components, velocity x and velocity y. However, we want to use these more randomly. So my x velocity, let's actually start with my y. My y is going to be random speed, basically that's what I'm doing, from 5 pixels per frame to 10 pixels per frame. So it's going to be, some clouds are faster moving downward, some clouds are slower. So to do this, I'm going to say that this is a random number, %6, right, which is 0 to 5, right, plus 5 more pixels. So anywhere between 5 and 10 pixels per frame. That's what it's going to move. That's the random number that's going to generate. And then inside of the x, I'm going to do something a little trickier. I'm going to say that I want a random number between 0 and 4, right? And I want to subtract 2 from it. So what this does is it creates a random number. So when it's 4, I subtract 2, so it becomes 0. And when it's 0 and I subtract 2, it becomes -2. If I just have 4 and, as an example, either way, it goes from +2, a drift to the right, to -2, a drift to the left. That's what it's going to do, randomly.
When you're in the constructor, why not also do the same scenario as we just did? set.
What do you mean?
So, because we don't set the velocity in the constructor, right?
No, I'm sending it here in the reset. So every time it resets, the velocity changes.
Okay, well, we can edit that afterwards, right? In the constructor.
No. Once you made the constructor set, it's set. That's why I call the reset first. I call reset in the constructor once, right? And then what happens is it gets called every time it checks bounce, right? All right, so yeah, so this is how it works. This is a reset. All right, so now, hey, this is all we need. I'm good. The cloud is done. Like, that's how fast it is. Once we have our pattern, I mean, we can make as many of these little game objects as you want in this way, if they're the same kind of game objects, right? Pretty much, yeah. All right, so let's check this out and see if it works. Make sure that this is cloud instead of island. Cloud. And when I do this, I'm going to go back to the the game.h. In my game.h at the top, I'm going to include the cloud now. And then after I've included my cloud, I'm going to come further down and define it. Now this is going to change. So I'm going to do something like cloud. I'm just going to leave this little bit of a space. My cloud is going to be of type m_p cloud. Okay, so we're doing one cloud right now. And then in my game.cpp, which is right here, I'm going to do the same thing I did last time, which is inside of my create game objects, I'm going to create it. m_p cloud is equal to a new cloud object. So I have one cloud. And in my render function, in my draw function, now here's something. I want to draw my cloud above my player. So I'm going to draw it last. So m_p cloud draw. And I'm going to update it every frame as well. So I'm going to go here and I'm just going to make a separation for the cloud because my cloud is going to be different. You're going to see why in a bit. Okay, good. So I've got everything I need for my cloud to be drawn and to be updated. You guys should know how to do this now. I've just added in updates the same way I did it for the island and the ocean. If I run this thing, are you good?
Yeah, we're creating one, right?
Yeah, for now. I'm going to make multiple of them in a second. All right, so yeah, let's try this out and see if it works. You should see, if everything goes well, a random cloud. So it kind of goes down to the right, to the left. Some are faster, some are slower, some are drifting to the right, some are drifting to the left. And it looks like it's different clouds just drifting down a certain way. So we have one cloud. Now, we don't have any collision with our cloud right now because we haven't defined that. Let's define the collision for the cloud. That's the next step. So in order for me to do this, the only thing I need to do is inside of my, there's two things. Inside my game.cpp, I need to check for collision with my cloud. So I'm going to call a new one. I'm going to say collision. That's my collision manager. The squared radius check. It's going to be m_p player with my m_p cloud. I'm checking player and cloud. Okay? That's my collision check. And in my collision manager, so that's the first one. In my collision manager, I have to actually bring up my collision manager.cpp. And inside here, where I have this little switch statement, I need to just detect that I'm colliding with my cloud by saying collision with cloud. Here we go. Are you with me? So two things I did to check collisions with the cloud. One, whenever you want to check collisions with any object, you have to have two objects to check. One of them is most likely my player. The other one is the other object you're checking with. Okay, so two things, object one and object two. Object one is going to be the player. Object two is going to be the cloud in this case. So when it's cloud, I want to say collision with cloud. And then in my GameObjectH, inside the update function, I also have to call another check of player in cloud as opposed to just player in island. By the way, there's better ways to do this. However, we're doing it like this. Okay, I'll come back to you in a sec. So when I run it, you should see this now. When I collide with my cloud, it says collision with cloud, collision with island, cloud, island, cloud, island, cloud. Are you with me? Do you have this? So I can collide with different objects now, and it detect which one it's being, which one I'm colliding with, which is important. Okay. There is still a problem. If I do this, right, with my code, if I kind of do this by moving my plane around really quickly, I get multiple collisions. Look, this is bad. I shouldn't be able to do this. This is a cheat. To fix this problem, if I do this, I don't want this to happen, right? To fix this problem, and I've kind of done it before, what I want to do is I don't want my collision manager to operate the way it does. Right now it says, hey, check. And if it's not colliding, then set colliding to false at the bottom here on line 47 on. I want to remove this part, this whole part, and just return false. And what I'm going to do is I probably don't need this one either. I'm probably going to go to both my island and my cloud and put the set colliding to the reset function. So in my reset function, I'm going to say set is colliding to false in my island, and the same thing goes with my cloud. In my cloud.cpp, in the reset function, I'm going to say set is colliding to false. All right, cool. So that's from setting them up in the island CPP, set is colliding to false, and in the cloud CPP. So what this does is it only allows you to collide with them after they've been reset, which makes it so that it doesn't matter how many times you pass the plane over that island or cloud again, you only feel the collision one time, right? Which actually is pretty good as opposed to multiple collisions with the same object. Okay, this is good. So I got my set is colliding to false here, and now when I run this thing, you should see that no matter how many times I pass my cloud or my plane over my cloud or my island, I only get a collision once. So notice if I go like this now, so I run my mouse really quickly, I only do one collision, no matter how many times I pass it over the cloud. I only get one, right? See that? All right, now that's it. That's this is the cloud and the island. Okay, cool. Are you all with me?
No.
What's the problem?
I'm still just fixing stupid mistakes that I made 5 minutes back.
All right.
So didn't spawn out.
While you're fixing those, so I have one cloud, but I want to create a bunch of clouds, and this is going to hit that part 2 of your assignment number 3. I want to make multiple clouds. I want to keep track of multiple clouds, right? There's a couple ways to do that. You could create an array of clouds, but I'm going to use a vector, all right? So at the top, in my core libraries, in my game.h, I'm going to include a new standard library called vector, okay? And the vector library is like an array, but it adds different functionality, additional functionality, right? So now that I have a vector, instead of declaring my cloud as a single cloud, I'm going to declare it as a vector of clouds or an array of clouds. I'm going to say something like this, std vector of type cloud pointer, right? And it's going to be called m_p clouds, pointer of clouds. And so I don't need this anymore. This is your cloud array. And also I want to define an integer value, which is m_p, integer called cloud num, which I'm just going to really quickly set to 3. Yes, I could do this inside the constructor, but I'll do it here. So this is like cloud stuff. And this is the cloud, the stuff from my cloud, right? Okay, but Now that I've done a vector of clouds, I want you to think of what I'm doing here. The stuff in the angle brackets is the type. So my vector is a like a list in C# or in JavaScript, an array in JavaScript. It's of type cloud array, a cloud pointer. And now what I want to do is in my game.cpp, when I declare my cloud like this, I don't declare one cloud. I need to declare a series of clouds. So the way to do that in my create game objects, I'm going to run a for loop. And I'm going to run a for loop that does up until cloud num. So from 0 to cloud num, I'm going to accept size t instead of putting integer. That's fine. And what I want to do here is I want to say that I want to push back. So m_p clouds, that's the cloud vector. I'm going to use the pushback function, which is like an add in C#. And I'm going to push back a new cloud object. A new cloud object is what I'm going to push back, right? Which looks like this. What this does is it creates an anonymous cloud that I attach to the array, the special array called this vector, and I'm going to do 3 of them. I'm going to attach 3 clouds. Yay! Okay, cool. So that's the first part. So first is making adding on to an array of clouds. Next, inside of my draw function, I can't draw one cloud at a time now. I've got to draw multiple clouds. So what I need to do is I'm going to use a special for loop, a for each loop. It looks like this: for cloud in m_p clouds. That's the for loop. That's like a for each loop in C++. I'm going to draw the cloud. Each cloud, for each cloud in clouds, draw the cloud. So that's what this is doing. Okay, you see that? So this is, it iterates through each of the clouds that I've set up in my clouds vector, and it goes through and it draws them all. Okay, I'm going to do the same thing for the update function. So in my update function, I'm going to take this little thing here, copy it, this thing. I'm going to go down into my update function and paste it. And now instead of drawing it, I'm going to do the update. So I'm just going to do this part. So in my update, I'm going to update. And you know what? This is a great place to check for each cloud collision. So I'm going to take this whole collision method out here and put it inside my for loop. So for each of the cloud, I'm going to check to see if that cloud is colliding with my player. Are we good? And you know what? Let's just move this collision because I want this to be in order. So let's, I don't know, if you're going to really do this right, then I probably would do something like this. In update, I'm going to check the collision with the player on the island, and in update, I'm also going to check the collision between each cloud for each cloud and the player. Each cloud and the player. Each cloud and clouds. Yeah. And so I'm doing this collision checking in the update method.
The player, updating each one, and then.
You see that?
No. So I understand what you're doing. It just feels weird to not check all the collisions after updating every. That's just me being.
Same thing. Whether you update and check afterwards, or I could create a collision check method that checks all of them. The problem with updating them first and then colliding, I'd have to do 2 for loops, right? Which doesn't make any sense. I'm already doing 2 already. I'm doing 1 here and 1 here, and those for loops take up a lot of cycles. And that means I'm drawing them first, drawing each one of them, and then after I draw them, I collide with, I move them all, right?
It still be 01.
It is, but it's not. I prefer not to do this.
Okay.
There's other ways to do this. All right. Anyways, so that's pretty cool. That does the checking. And so now what I have, without doing anything else, right? If I go back to the code and if I run it, I should see multiple clouds, 3 in fact, that look different, that are actually moving in a different rate, right? And I should be able to detect collision with each of them. So here's cloud, 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 right? Island, cloud, island, cloud, cloud, cloud. And some of them are moving faster. Some of them are moving slower. Some of them are moving to the right. Some of them are moving to the left. Some of them are moving straight down. Yeah. And this is okay, but you know, it would be really nice if I could see transparency. I want to have these clouds be transparent. So instead of it being like a solid cloud like this, I want to make it so that the cloud itself is transparent in my code. How do I do that? So let's do that. By the way, this takes care of part of assignment 3, part 2, because I have multiple collisions detecting on same object multiple times. Examples, instead of clouds, bullets. So what I want to do here, in order for me to set up my transparency, I need to change my texture manager a little bit. So in my texture manager, .h, I want to set up a new function, which is going to be a setter. So it's going to be void. I'm going to set alpha. I'm going to pass in a standard string, which is the ID of the texture I want to set the alpha to, as well as a uint8, if I'm not wrong, which is a number between 0 and 255, which is going to be the alpha value, right? So that's what I want to do. I want to set an alpha. I want to make a new method for this. So I pass in which ID, which texture I'm setting the alpha value for. And if I go to here and create my definition inside of my texture manager.cpp, I'm just going to open that up. And I could have done it there, but it's okay. So here's my texture manager.cpp, and I have this new setter, which is going to be down here, set alpha. And I need to do 2 things. One, I need to create a new SDL texture pointer. So here's my new SDL texture, a pointer to that, which I'm going to call a pointer to a texture pointer, right? And I want this texture pointer to refer to the texture pointer that is inside of my map, which is m_p texture map, right? And then with the ID of ID, I'm going to make a reference to this texture map. So whatever the ID that I put in, for example, cloud, it's going to say, hey, get the cloud reference, a reference to the cloud from my texture map and assign it to this temporary pointer, right? Once I've done that, I can use SDL underscore, and I want to set alpha. So if you actually go to, there's set color key, and if you look at alpha, if I just type in alpha, no, I think it's actually SDL alpha something. I go set, is it set alpha? Here it is, set alpha mode, this one. Instead of set surface, I want to do set texture. Set texture alpha mod is what it is, right? And if I open this up, it gives me 2 things it needs. It needs the texture, which is p texture, and my uint8, which is the alpha value. What this does is it says, hey, for this texture, I want to set the alpha value to whatever I want. And I want, let's say if I want to make it 50%, then it'd be like 128 out of 256 or whatever it is, right? That's 50% of the alpha value. So it means alpha transparency, right? So now that I've done this in my texture manager.cpp and I've defined it, in my cloud.cpp at the top, where I'm defining my type and all that stuff, I'm going to use the texture manager instance, and then I'm going to set alpha of my cloud to 128. This is like 50% alpha, so it's going to be 50% transparent. Now this is going to happen for all of the clouds because remember they all share the same texture. if I randomly did it, it would change.
I know.
Yeah.
Just thinking about other ways.
Sure, there's tons of ways to do the same thing. Yeah.
Make a setter because I'm a terrible.
Yeah. You can do tons of ways, right? So if you look at this, now we should have 50% alpha clouds that are partly transparent or half transparent, like this. So I have 2 clouds, and then I can still detect the clouds, but they're partly transparent. So it looks a little bit nicer. Our little game is starting to shape up.
You could also mess with that setter, and then when it hits it, the transparency to...
It's tons of ways, right? There's tons and tons of ways to do this stuff. You can make, remember, this is just, you know, we're scratching the surface of what you could do here, right? So this is pretty good. So we got like a little game. It kind of has some interest with it. Now, next part. To satisfy your requirements for assignment 3, I asked you to make a sound, right? For each of the times you collide with the bullet hits your player, there should be a sound, right? And in order for you to do that, I've uploaded a sound, an audio assets. If you look at your Blackboard, there's another audio assets. Please download that. And if you do that, I want you to place it inside of your assets in here. So I've already got that. I'm just going to pull it in from another folder. So I'm going to make, so example, you have an assets folder that says audio as an example. I'm just going to pull it from somewhere else. And here it is, audio. So I'm going to take this whole, you just undo, if you unzip it, it'll say audio. And if I take this and I put it inside of my SDL templates under assets, I want you to just make another folder called audio. And in the audio folder, there's 3 audio files. Actually, there's a bunch of them. But there's 3. The ones I care about are Thunder, OGG, Yay, OGG, and Engine OGG. The rest, I have some extra ones. I'm just going to remove these ones because I copied them from somewhere else. I'm just going to delete them. So you only have the ones that you care about. There we go. So I have these 3 things: Engine, Thunder, and Yay OGG files. These are using OGG Vorbis, right? Music or sound format. It's an open source sound format. Okay, so good. Now that I have this, and if I want to include sounds in my, every time I hit my cloud or my ocean or whatever, or sorry, my cloud or my island, I need to include the sound manager in here, right? So what I want to do is when I load up my sound, my island, I want to instantiate a new sound for my island. Okay, so in my island.h file, I'm just going to go over to the H file. And again, you can put this here too, but I'm fine with putting it in the island.h. So if I go to island.h, not only do I include my texture manager, but I also include now the sound manager that I gave you. Sound manager. I'm going to do the same thing for my cloud just to be preemptive. So take my sound manager and go into my cloud.h and include it there too. And I might as well do this in my plane, in my player. So I'm going to go into my solution explorer. I'm going to go to my player.h and put it there too. Now, theoretically, I could have included texture manager and sound manager inside of another file like game.h, GameObjectH, and all the other ones would have it. But that means that all game objects have sounds and textures. Maybe they don't. So that's why it's probably better to do it this way or some other way. Okay, now that I have references to the sound manager, the sound manager works very similar to the texture manager, right? So in my, let's start with my island. So in my island.cpp, if when I load my island, I also want to load the island sound, right? The yay sound. So I'm going to say something like the sound manager instance load, and it's going to need to a couple things. One is the reference to where it is. So .. / assets audio, and then the sound that I want to make, which is yay.ogg. And then the sound type. And remember, it's sound type, : special effects. Sorry, not music, that's effects. Because that's a small little sound that I'm going to make. Why isn't this working? Is not that one correct? Sound Sound effects. Yeah, it was. So maybe did it run? Oh yeah. Sorry, I need the sound, the special sound too. So it's going to be called yay, and then that. Let's put this on 2 lines so you can see it. Doop. So yay is the friendly name for the sound. It's going to be called yay, right? The yay sound. The sound type is sound effects. All right, and I loaded here. This loading stuff, it actually preloads your sounds when you create your game objects. Okay, I'm going to copy this one, and I'm going to do the same thing for the plane and for the cloud ahead of time. So I'm going to go to cloud.cpp. In my constructor, I'm going to do the same thing. So paste that in, and instead of yay, it's going to be thunder. Every time I hit the cloud, it's going to make a thunder sound. By the way, I did not record these sounds. These are from another game. Actually, I have to give props to Andy Harris, who's the one that created all this little demo, and I've been using it for years. All right. So I'm going to take the thunder. The thunder sound, and I'm going to copy it into my player. So in my player.cpp, again, bring up my player.cpp. It's going to be slightly different. My player is going to play the sound, but it's going to be more of a continuous sound. So my player's engine, which is this one, engine.og, it's called engine, but instead of it being a sound effect, it's going to be music. All right, so here I've preloaded the sounds. In the constructors of each of the objects, I've preloaded different sounds, okay? And now to play them, where do I play them? I'm not going to play the player sound first. Let's just start with one sound at a time. So in my collision manager.cpp, right, my collision manager should also know, actually my collision manager.h should also know about sound manager, right? So if I go to my collision manager.h, I should also know about the sound manager. So I'm going to include that in here. Include sound manager, my collision manager.h. And if I go to my collision manager.cpp now, inside the collision area where it says, hey, I've collided with an island, I collided with a cloud. Hey, take a look. I also have bullet and enemy set up for you, just in case. Who knows why, right? If I want to make a collision with an island, I want to do something like this. I want to say the sound manager, right? And I want to play sound. The sound I want to play is the yay sound, and I want to play the sound only one time. I don't want to loop. And it doesn't, by the way, it doesn't look like this. It goes instance, play sound. Instance. How did I do it? Sorry, one sec. Instance, yeah, with a capital I. That's it. Okay, there we go. Instance play sound yay, and then 0 means I don't want to loop it. I want it to loop no times. Okay, I want to copy this whole thing, and I'm going to put it in the cloud. And instead of the sound manager playing the yay sound, it's going to play the thunder sound now. So when I hit the cloud, it makes a thunder sound. When you hit the island, it makes a yay sound, yay, like that, right? Let's see if this works. Maybe it's going to work. Maybe it's not. Let's see. That's pretty loud.
Yay.
That's pretty loud.
Yay.
I'm not physically trying to make the sound really loud, by the way. It's probably just my sound is really loud. Let's try to turn that right down. Let's try that again. Yeah. Right? This satisfies your requirement for assignment 3 in terms of how to make sounds. All right, one more thing to note is I have this engine sound and I want it to play forever, right? So let's add the engine sound. When the player is instantiated, not only do I want to load the sound, but I want to immediately play the sound forever. All right, so I want to do right here inside the player.cpp in the constructor. I want to say the sound manager instance, play music this time, and I'm going to say that the string, the ID is going to be engine, and the loop is going to be -1, which basically says I've set it up so that -1 means play forever. And now here's the complete version, if it works properly, which it should. You have a background sound,
Yay.
and then
Yay. 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 Yay.
okay, and we have the beginnings of our game. Things that are missing from the game. You don't have. I'd like to have a score. We're not going to do that today. You know, but we could have a score. We could have some kind of multiple scenes. But you should be able to make your sound play given what you've given. Okay, so somehow, if I went too fast and you missed some of the code, you can find it on GitHub. It's already done for you. So if you go to, so if you go to github.com / George Brown College, right? If you look at lesson 14, it's already there for you. If you look at all the code, so in the source code, you can see that I've got the island and the clouds. Here's my cloud as well. So here's my cloud.h and all that stuff. All that stuff is here for you, similar to what we've done today. It may not be exact, but it's very close. And now, if you're going to download from GitHub, things to note. Sometimes you'll get things like, I don't know where the library is, right? Why? Because Visual Studio, it uses a gitignore file that removes certain files from putting up on GitHub, like all your garbage files. But it also ignores libraries and all that kind of stuff. The assumption is that somehow your project is going to generate the libraries for you. It's not going to, right? It's not set up for that. So what you need to do is download my Blackboard, my stuff from Blackboard, and modify the Blackboard stuff with the things from GitHub. Like you can download 2 projects, the GitHub project and the Blackboard project, and then copy paste the stuff from GitHub into the Blackboard project, which will have all the libraries and set up properly, or the other way around, take the libraries and put them into the Blackboard, into the GitHub project, right? But you have everything you need here between these 2 things for the code. All the code samples are here, as well as, and the actual project is on Blackboard. Any questions? I'm going to go around now for the remainder of class and make sure that all this stuff works, right, for all of you guys. So if it's not working, stick around. We'll try and make it work. We'll go through some of the problems. If it is working and you've got it all good, see you later. Good luck next week for your exam. I'm going to give you your, the exam should roll out sometime on Monday, and you'll have the whole week until Friday midnight to complete it. What? Earlier, maybe. I'll see. It's just
be very helpful to get it this weekend.
If I can, I'll do what I can. I can't promise that because I've got other things going on. I got other competing issues, right? So otherwise I would. All right. Otherwise, is there anyone else that has any questions? Okay, if you're sticking around, I'll go around and help you guys out. If you're not, then good luck.